Hello everyone, my name is Tamina and in this video I want to explain an optimization problem in the simplest way that I can. An optimization problem means finding best value for our objective function. We need to define two things in an optimization problem. First of all, our objective function, for which function we want to find best value. And second, we should define our feasible area. It means where we are allowed to find our optimal value, our solution. Um, so the general form of an optimization problem is like that we have a maximization or minimization problem. In this PowerPoint, I want to continue with maximization problem. We want an maximization problem of our objective function, which is f of x, and we want explain or define our feasible area with several conditions that we have here. First of all, we can have equality as our conditions, which can be several functions like gi, and they should be equal to 0. And if we in this side we have a number, we can take this number in the other side and put a 0 here. And we have also have inequality as our condition, like a j, and we can have several conditions here. We should know in which area we can define our function, and we should stay in a domain and dimension of domain of our objective function. So first of all, we should know which domain has our objective function. We assume that we are on Rn, and n is an arbitrary number. If a p star is our solution, it means that it is infimum of our objective function f of x under these conditions, and it means that x should satisfy in all of our conditions: equality, inequality, and all other conditions that we explained for our function. But it means that p star is infimum value for our f of x. If p star is equal to infinity, it means that our problem is infeasible. We cannot find a solution for our function. It is because our problem is minimization, and if p star is equal to plus infinity, it means that our problem is infeasible. And if p star is equal to minus infinity, it means that our problem is unbounded below, and for maximization is vice versa. Okay, and we should also know our optimal solution is global or local. Global means that our optimal solution, our optimal value that we find is true and is the best value over whole domain that we find for an optimal solution. But locally means that our value is only true for a neighborhood in our domain. Sometimes we cannot find a global optimal value for our solution, and we can only find locally optimal solution. For example, when our problem is unbounded below and above. And so we can define a neighborhood for our problem and search for best value in this area. I have here a very simple example of optimization problem, and it is I want x minimize the value of x plus 2y, and I define my subjects, my conditions as x plus 1 larger equal to 1, 2x plus 1 less equal to 5, and I want to search in this area when x is between 0 and 5 and y is between 0 and 4. So I have here a graph of them, and I have here all the line that I want. It is when my x is between 0 and 5 and y is between 0 and 4, and I have here the other two lines, and this blue area is my feasible area, and I want to assume that x and y should be natural number. So I can try natural number in my feasible area and test where x plus 2y has the minimum value. Here, for x equal to 2 and y equal to 0, I have minimum value for this x plus 2y, and so it is my a minimal value, my optimal value in this case. It is I think the simplest example of an optimization problem is too interesting area, and it has lots of applications in real world. And in my future video, I want to explain about other optimization problem and lots of interesting things in this area. So if you find this video interesting and helpful, please like it and subscribe to my channel. Thank you for your attention.